Yes, hello. Welcome to this presentation, Digital PLM 6 Advanced Artificial Intelligence, Scaling Up with Digital PLM. Now, what we are looking as of today at the agenda, here the proposal. First, we will go into a preparation introduction phase. Then I will tell you a little bit about hype topics and their impact on PLM. Introduction artificial intelligence will follow. Architecturing PLM for artificial intelligence is the next topic. Then we will see the impact on PLM and artificial intelligence itself. Also, there might be an exercise. This is not part of the presentation. This is a separate part and a separate presentation. Then we will see digital PLM new topics and a conclusion. Preparation and introduction. Now, see here, I am not reliable for the contents of the links. I am not reliable they are pointing to, and I'm not reliable what I'm talking here is about my own view and not the view of my business. So this is most important for you, that I'm not liable for content, nor for links, nor for these topics which are on the links side. Okay. Agenda proposal. Now this video will go around 45 to 50 minutes. Usually the agenda is as follows, that we start with the introduction and then we do the practical exercise, which I told you, but this is not part of this video. And then we have a Q&A session at the end where the students can bring in their questions and get their questions answers. This lecture will be held in English. Everything is based on interaction. If you want to take break is on demand. Take your time. Now we are going with a mobile lecturing, and I want to ask you not taking any pictures, please. If you want to copy and innovate. These are the lecturing devices. The devices are the laptop devices, also the smartphone, and if you have a tablet, you can also use this for lecturing. Working in a multi-mobile world and environment, this lecturing is designed to be digital. If you are now going to prepare your device, please, you will find here the presentation from the class, and that's on the internet site, and you can download it and follow it on your laptop or on your device. Now the videos from the last lecturing in the last semester can be found on YouTube. Artificial intelligence on the right side is in English, the other one is in German, so it's Artificial Intelligence 5. And you can download it as well in the internet as videos, and you can see and watch it on YouTube. Okay, now this should it be for the introduction. We are going to see now more on the content and the hypes and topics and the impact on PLM. So we will see the technology hypes which are behind that, which are driving PLM. Then we will see some of the general hypes which we have to watch for digital PLM, called megatrends, and the hypes for watching for digital PLM, which are the trends for digital PLM in the future. If you look at this chart, you can find it at visualcapitalist.com. It's a very nice site. It has a lot of graphics on it according to the data. They have analyzed, and you will see that a lot of hypes are in there the last few years. Now, if you see, for example, in 2014, starting with IoT, then the speech translation, autonomous vehicles, and so on and so on. It's up to 2018. I didn't found a new one. But what we are looking today in this presentation is a little bit more about machine learning, deep learning, and deep neural networks, which is in some called artificial intelligence. But nevertheless, there are some more trends around that which you have to watch. And these trends, it's very important to also follow these trends because they will impact future PLM. So, to mention it, we are going to see and have a look on cloud computing. Now, cloud computing is very interesting because cloud computing comes from the internet and you can all access it via the internet. Cloud computing is computing power in the internet where you can subscribe to as a service, for example, and take this service and put on your machine and follow this and also put some calculating power behind your scenarios. Okay, and in 2013 you see here big data. Big data was a very interesting approach topic coming to the intranet of the companies. Now what we do here is we have big data which is collecting sequential data and not structured data anymore, and you put it all in one big file. But the important thing is how to find this data afterwards and how to manage this data because they can be very large. So if you have, for example, a sensor or device which is streaming a lot of data to the internet, you have to follow all the data, and it's very important that you calculate only with the data which is moving and which is different from the other before. And we need that for Internet of Things. Internet of Things in the devices and in the sensors, you have a lot of data coming to the internet and coming to the big data machines and big data databases. And you have to figure out what is the right data and what is the data which is important and what is not important. This will be a topic afterwards from edge computing. And you see that the next trends we have is blockchain. Blockchain is an approach to store records of booking and records of payment, and this cannot be changed in the blockchain anymore. So it's in and it's valid, and it's important that you have a right booking sentence. Now the next trend is edge computing. Edge computing, as I told you, in combination with IoT. IoT is the thing that is streaming all the data through the internet to the big data devices. But if you have not moving data or moving the data which is not really going up and down, which is not really changing, then you don't have to bring all the data to the database onto the big data approach. So edge computing will prevent you from sending data over the internet, which is always the same and which is not changing. Only when the data is changing, then you will come through the edge device to your big data database. And the next thing which is very important is quantum computing. You have to look at quantum computing because quantum computing is able to store the bits and bytes in the electrons of the atoms of the atom physics. So you're getting a deep integration in the atoms and not stored on silicon-based chips. And this will improve and increase the storage amount, and this will improve and increase the reliability and how fast you can access these bits and bytes in the quantum computing area. Now the next thing is IoT platform. IoT platform is you are going to implement a lot of IoT devices and you're bringing them together to a platform and you can operate them all in a platform concept. For example, within a company in the industrial area, and you can also do this in the internet, and you will connect all your devices to these platforms and you can access all these platforms through these platforms, all your devices, and manage this with this platform concept. So at the general speaking, the general hypes to watch for digital PLM are quantum computing, edge computing, what I told you, blockchain to make sentences of bookings, a big data approach to store large data, cloud computing to really go into the internet, IoT, Internet of Things, and also coming up in combination with IoT platforms. But what we are looking as of today, due to the topic we have, is machine learning, it is deep learning, and we are looking at deep neuronal networks. And all this stuff has to be watched for digital PLM. Digital PLM will increase a lot with these new topics. Okay, we are in the introduction phase of artificial intelligence. We will have an overview on artificial intelligence, then we will go into the distinction between machine learning, deep learning, and artificial intelligence. We will have some thoughts on Industry 4.0, IoT, and artificial intelligence, and I will tell you a little about the lecturing at the HNU. So, overview. Everything is a broad concept. Artificial intelligence is the complete overall description and topic, and part of it is machine learning. And machine learning is, if you go deeper, it's deep learning. We will distinguish it later on, but this all is mentioned if you're talking about artificial intelligence. And artificial intelligence has usually artificial input and artificial output, which is simulating the natural voice, aids, and pictures and videos from the human being. And on the output side, we have speech, movement, and working, physical work. So these are artificial intelligence definition. Input is human input devices, you could say, eyes, voice, and ears, so for example. And on the other side, you have to speak, and you have to move your body, and you have to lift some weight. So this is, when we are talking about artificial intelligence, we are always simulating human intelligence. Artificial intelligence is this broader concept, yes. It's the cognitive function of humans, which is be simulated. And when this is done by machines, we simply say this algorithm is intelligent. That means it is artificial intelligence. You will find some other links beyond, and on these links you can follow and see the differences and the definition in the internet. Machine learning has always one input vector and one output vector. This is very important. Machine learning means you're learning from one input, for example, from speech or from flow of pictures or from videos, and you have one output signal. So this is very important that you know that machine learning has a very limited behavior. Now, machine learning is to learn from the data which is input data. And from learning from this input data, there's information about the processing to the output side and to the output vector. So deep learning goes a little bit deeper, because deep learning is deep in the sense of more than one input and more than one output. So we have a really deep neural network in between, and you have 2 or more input vectors, and this will make it much more complex. So to bringing it together and to show you here in one picture the difference between machine learning and deep learning, in general speaking, is you have in machine learning world you have only one input vector and on one output vector, and on the deep learning world you have more than one input vector and you have more than one output vector. So this is the main difference if you're looking from the technical side at machine learning and deep learning. Okay, for the introduction, now we have to distinguish and to see where artificial intelligence is brought into account. So if we are looking at the Internet of Things, then we can see that it is either in Industry 4.0 context, which is more in the intranet of the enterprises. For example, in German, they have Industry 4.0 terminology for that. Or it's more in the IoT context, which is in the cloud space. And this is called the Internet of Things. This is the really Internet of Things. And you can always bring these IoT devices through a hub concept to the cloud. There's always this possibility to connect all IoT devices to the cloud. Now, artificial intelligence is more in the Internet, and it's more on the international data centers. So you need to have access to the international data centers which run artificial intelligence, and this is a part of the digitalization topic, digitalization in the term of digital transformation. We are moving all to the internet. The intranet is limited. If you want to reach devices, if you want to reach things, if you want to reach customers, you have to go over the internet. So the state of the art is that the baseline is always more moving to the right side in terminology and in sense of digitalization. And this will be the main topic of the transformation in the future. If you have a look at the lecturing at the HNU, we will find some very meaningful and powerful scenarios. In the past, we had a small Raspberry Pi connected to the IoT world. Then you have to monitor a sensor and you bring it to the IoT world. For example, for Microsoft Artificial Intelligence Framework, and you monitor the sensors and you find thresholds, lower or upper thresholds, and then you have impulse or warning lamp or warning flag. So the next was Mission Mars. Mission Mars was writing a part or piece of code which was damaged on the Mars sonde, that they couldn't go back and that they didn't take off and communicate really with the people on the Earth. So we have to figure out what the problem was and rebuild this subfunction and subroutine and transfer it to the Mars sonde and then integrate it there in the working environment. And so we could communicating with the Mars sonde again. Artificial intelligence and frameworks was the next topic. I started with IoT scenarios in the internet, also the famous provider of IoTs scenarios for PLM were there, and the first time were there. So we see a little bit of industrial Internet of Things connected to the framework of Microsoft, for example, or others. Yes, and then in the summer semester we got Udemy. Udemy is a course provider, and it has very good course, self-learning, self-paced courses. And these self-paced courses cost only a few euros or a few dollars, and everybody can afford it. So I took this to manage it and to see how artificial intelligence is working. And also I will stay with this for the next semester, because this is a very important and very showable and very pretty neat example of how to use artificial intelligence over the internet. Yes, this was the lecturing done at the HNU, and I built it up all the times from scratch. But we are looking now a little bit at the architecture side of PLM and what has to be done at the architecture side of PLM that it can be used for artificial intelligence. So this is tricky, because usually what we all started with is on the left side. This was the really beginning of PLM around 2011 to 2015. There were some parts missing, but you see clearly ALM, PLM integration was the main topic, and then we put on Office integration on it, we put on cloud technology on it, and ALM, PLM integration was always the topic again, which is requirements management. So then IoT Hub comes the first time. How to bring in IoT Hub. And visualization also was a very important topic. It's also still a very important topic to visualize the product into the space and to see and to bring it into the front of the customer. Okay, the next phase was phase 2, so around 2013 to 2018. This came from mobility, this came from digitalization, and IoT and artificial intelligence was coming up. But what was the main reason? Now, the main reason was the big data approach in the middle. You find it in the middle of the square, of the cube, and in the middle of the cube you see the big data. Big data was there, and big data was the most important thing to store all the data, which is sequential. So you will see that this was a very important step. And phase 3 will be nevertheless even more important. This is the scale, how to scale PLM to digital PLM. And scaling is the most important thing. Scaling is the most important thing to scale for growth and monetization, and to scale all even in the internet. And if you have products which are running and which get data back from the internet over DevOps concept, and you can combine it with technology, and you can combine it with the development department, and you can combine it with the business in the thinking of payment and yes, optimizing payment, for example, or service optimization. Digital PLM transformation. Here you see it again. You see it, we started from classic PLM, from project management, requirements management, and the PLM-ALM integration. Then we went through the technology shift with big data and with cloud technology, and for example also with social media. and this was the birth of digital PLM. Digital PLM was around 2015 when in Germany digitalization project was done from the government. Digital PLM will scale even more. Digital PLM will go into the area of business with blockchain approaches, with monetization, and digital marketing will also be a very much an important hype. Here you see the digital PLM transformation. Transformation is always from one point to another point, and you have steps which are following in the middle, and you can do this on the technology shift side, and you can do this on coaching side. So here is the technology shift side. You have to have the traditional approach with ALM and PLM and IoT hub. You transfer it to a more, let's say, more appropriate scalable functionality in the internet, and you're going this way all the steps up to the hill, and you're adding value to PLM. Now, how the scaling comes from, where does it come from? It comes from quantum computing, it comes from cloud computing, it comes from edge computing, from blockchain and big data. These are the technology drivers I mentioned in the beginning, which are driving digital PLM, which are driving PLM to the internet. Here you will find the providers. Here we will find the digital PLM providers. As you will see, the IoT is more or less moving out of PLM. It is more structured data. This is in the enterprises, in middleware and intranet. It's so HP, for example, or IBM or Dell, they are all working in this area. But what we need for digitalization and for digital PLM are more concepts for internet, and you see, you name here the 5 big companies for internet. They have the most impact also on digital PLM. And this will also drive IoT platforms, this will also drive artificial intelligence platforms, and this will also drive digital mobility platforms. These are the topics we have to look at for digital PLM. Okay. Impact on PLM. What is important is artificial intelligence, and why is it a really big wave? Now, as we got big data, we are able to connect all devices together. As we get neuronal networks, we are able to calculate and to find over machine learning algorithms what is the really going on what is possible with these devices. And when we get GPUs and CPUs for cheaper, we can also do this now much more efficiency in the cloud computing technology centers and in the cloud computing technology centers which are working with GPUs, for example, for instance, from NVIDIA. Also, there will be new job descriptions available for artificial intelligence engineers. It will change a little bit. The working environment will change and the job role will change. So we'll find at the moment 3 things which are put together and which are domains: data, selecting data, gathering data, and data preparation. This is mostly done by data engineering, by data scientists, and also maybe by platform architecturing. So these are more the data recognition side. Then modeling and training it. This will be the software developers or the hardware developers, dependent on the amount of data, and how to bring it into the companies and how to take benefit out of it. This will be done by consultants, integrators, by managers, and so on and so on. And underneath, we need some infrastructure provider. We need the project management. We need the governance. We need the tool chains and the data science and data services. And also, I think a little bit missing is legal issues. Legal issues is very important. Okay, I will give you 4 examples for artificial intelligence and big data analytics. Now, the first one is gas price, changing gas price from a big company. If they order gas, then it is possible to have one piece which is fixed and one is volatile. And it's the question, what is the input source and what is the real impacting input for the output. So the changing of gas and price afterwards can be qualified and quantified. What is the real trend component and what is the part which is random. Now we are going to the next, fleet optimization. If you have a fleet, for example, a lot of trucks, then you always want to know what is the best truck. What is the best truck in terms of reliability, no overhaul or no repairs, and what is it in terms of mileage, how many mileage you can do with it, and what is the best in terms of buying it and operating it. So if you have a fleet, there is different AIKI trucks or with buses. You always have to manage it with a big data approach. You have to always gathering data from your cars, from your trucks, from your buses, and optimize it and see, are they in the green field or are in the yellow field or are in the red field? Are they operable, profitable, or are they unprofitable? You're making loss of it or you're making money with it. So this is very important, and you can bring in on the big data database, you can bring in artificial intelligence algorithms to figure out and to make it graphicable available. So now the next is build analytics and picture classification. It's quality assurance. If you have a quality issue and you want to do a quality assurance on material, you all have done it by laser, and you always will do it by laser today. And you also can do it by picture, and you can do artificial intelligence after it, and you can find the problems with artificial intelligence, whether the picture was okay or whether the picture was not okay. IoT-based cost optimization. Now if you have, for example, a park and you have garbage cans in the park, usually what you do is you're going from one can to the other and you don't omit one. You always have to reach out for all cans, and you have a lot of driving mileage to empty all the cans in the park. Now what you can do is you put on a sensor whether the trash can is empty or not, and with that you are able to distinguish. You don't have to go to the empty trash cans, you only have to go to the full or half full trash cans, and then you are optimizing your route, you're optimizing your fleet, you're optimizing your money, and you're saving money. So these are 4 examples I wanted to tell you for artificial intelligence and big data analytics. And this makes it most convenient for industrial purposes and for customer services that you can save money out of it if you're doing artificial intelligence. Now, we are deep diving in artificial intelligence. We will have a look at the algorithm, then we will have to train the model, and then we will have to put in the model in our algorithm and apply it to our problem. This is the step, and this is the way how artificial in general always works. You always have these steps. For example, here the machine learning algorithm is a mathematical equation set of mathematical equations, and this is mostly done by sums and by exponential function. And this is very easy to calculate, and this can be done very fast, and this is very simple, but it cannot be really done by a human being. It's too complex and it cannot be done by hand. So for example, if you want to have now a running artificial intelligence environment, you have to first train the model with sample data. Okay, sample data, you know what is on the picture, and you classify them. You classify them by hand, and you say, give him a label, and the label is what is coming out, and in which not the label will fall. And with that, you're training the model, and you're getting a model which according to this sample data. In the next step, you're taking this model and the algorithm of the model you put in your data. You apply the model to your algorithm and you put in your data. And with your data, you're training the model again. You're training the model, and you figure out what are the answers and the predictions out of your data. This is very important to understand, that you always need to go these two steps. Generally applied to your problem means that it is always data coming from your side. You have the trained part in the middle, and you're now getting the answers. It's always in this way, and it's always in these steps. Now see, here you're preparing machine learning for and also deep learning in two steps. Now the machine learning algorithm I showed you, the first step is always train the model. The second step is find your answers and your data according to the trained model, and you apply it to your problem. This is the way it works always in machine learning, deep learning. Okay, at this point of time we always have the exercise, but we will omit it for now. It's an extra video, and we will continue with the lecturing. Digital PLM will have a lot of new topics. Digital PLM lecturing will involve, and also digitalization will involve in a kind of evolution. Then we have the vehicles which will involve for digitalization of vehicles, and I want to show you a little bit about digital mobility. Digital PLM lecturing, classic PLM lecturing was done 2014, and then we brought into the cloud concept and the integration with the cloud provider and the requirements management. That was what I call basic thinking, bringing the PLM to the integration, good integration standard, and make it available in the cloud. Now the next point and the next idea was the business transformation part. Cloud visualization and also a little bit of cyber war in the PLM space and PLM in the cloud. average thinking, we see we have nearly doubled our hits in SlideShare. And the most advanced was then the strategy how to virtualize the PLM stuff or run PLM as a service, and how to do Office integration in the cloud and how to bring PLM to the cloud. We scaled it. We scaled it into the internet. From the very first beginning, we scaled it to the internet, and we are hit more than 3 times and more hits on the presentations in the internet on SlideShare. What is coming next through the digital transformation in PLM is IoT, artificial intelligence, digital mobility. I told you digital business scaling is ongoing. We are also talking about small, medium businesses. And what we see is we need a new provider from the internet network, which are Microsoft, which are Amazon, which are Google. They drive it to the internet. Now, digital evolution. At the very first beginning, we had analog world, so we had machinery, and we paid for this machinery. So this were very basic. Then we get an automatized world in the internet. It's industry of things, it's big data, it's mobile. Here everything was connected, and we had a value-driven chain. We are doing value-driven chains on the automized level. And the next issue was to virtualize it. This was part of the digital transformation and the service orientation. And this is the disruption, and the disruption is coming and breaking in, and it will do the data-driven value chain. So we have in the internet a complete value chain which is based on data. And this leads to a disruption. This will disrupt everything. And now we are on the stage of autonomized. So we are intelligent, we are autonomous, we are working with blockchain and value-based monetization. And this will lead to the digital evolution and will have a lot of technology drivers behind. So this is the digital evolution in general, not only for digital PLM, but this is the overall agenda. Digitalization of vehicles, from the classic automobile through the navigation, through smart devices, for example, and autonomous and digital. So you're starting from the basic cruise control, and you're getting more and more benefits through the navigation. You're getting active traffic control and coordination through supervising and monitoring, and you can do all the financial transactions via blockchain technologies. So this is the digitalization of vehicles. Digital mobility. If you're looking at digital mobility, then you will find autonomous shuttles, for example, here from YouTube, or you will find Mobili. Mobi is a mobile open blockchain initiative, and you will see here the website, and this is a very interesting concept which is coming from California. And they have brought a very important concept in combination, how to manage the traffic on the cities, in the cities, and in general overall. Okay, now we are going to the few slides of the conclusion. What I want to mention is that you have the availability to give course feedback. If you please go to this website and figure out the questions and shortly give an answer to making this lecturing better. And also at the end of this course feedback, you get a free access to my digital PLM groups, where all the students can come in on a free will basis and where all the interested peoples are in. So the next to mention is a book, Neuro Leadership. It's a German book. It's from Professor Trutschig from Landshut and his students. You will find a new approach how to see an enterprise. It's more organized like trees. Then it's digital management and knowledge management. Then he will talk a little bit about platforms, digital value, and also engineers about digital problems. Artificial intelligence is the main one. It's a definition, and in Germany, supply chain management and also managing data through the supply chain. Then we will have a lot of sensors in the car and artificial intelligence in the car and a lot of embedded and smart city stuff and also speech recognition, which is coming to the car. So he is dealing with that. It's very good. It's very interesting. And there will be a continued learning process in the information and knowledge society. Digital business models is his next book. Digital business models and the benefits, Industry 4.0 and information and communication technology, consuming media and financing, Umwelt is environment, state and financial departments. What I didn't find here and what I told Professor Trutschig is the issue about digital mobility. So digital mobility is a really big issue, and it's not in this book. I mentioned him that he should done a new book on that. Okay, if you want to stay with me, you can send me an email to ask questions anytime if you want on digital PLM strategy. This is my email address. I'm also publishing a newsletter for digital PLM, which is coming twice a year. It's in the springtime and in the autumn time. And if you want to put in your email, you can register here. You're also getting here a freebie for your registration. Okay, if you want to have more information, for example, you will find my digital PLM.de website on the internet. There's also digital PLM videos on my website. These videos are for free. For example, one is how Tesla was coming to the German market, how you could see how it was coming to the German market. Then where to find important qualified information about digitalization with course provider for free. This was one. And what was the impact on the development operation cycle of the cars, of the trucks. You can see a car as a service, and you can manage it over the complete digital life cycle. And also here's the link for the work I have done for the HNU in Ulm. So, yes, coming to the conclusion, I hope you had a very interesting presentation. I hope you had a lot of topics covered you were asking and looking for. I'm dealing with all this stuff, and my idea is to make outstanding analytics of the actual questions of the digital transformation enterprises. And I'm using for that a network in the internet around vision. These are my pillars: business strategy and platform innovation concepts. And if you want to reach out for me, you can find me on the social media. This is for sure. Look for Digital BLM and Digital BLM Strategy. And you also can reach me out via telephone or via email. Thank you very much for listening. We made it finally to the end, and hope you can benefit from this presentation, and we'll see you maybe in the next lecturing.